Today we will be solving this question. Here we are asked to compute the limit of the function log to the base 5 of x divided by log to the base of 2 of x minus 8, where x tends to infinity. Note that here both the logs in the numerator and the denominator are of different base. So your first step is to make the common base by using this property. So log to the base of 5 of x becomes, here we are changing the base of 5 to the base of e, which is your natural log. So that is log to the base e of x divided by log to the base e of 5. In the original formula, your base was b, which in our case is 5. So in the denominator, you have the log to the base of e of 5. Note that here we are taking the base of e, which is the natural log, which can also be written as ln of x divided by ln 5. Similarly, your denominator log to the base 2 of x minus 8 becomes log to the base e of x minus 8 divided by log to the base e of 2. So this becomes ln x minus 8 divided by ln 2. Now your original function was limit x tends to infinity log to the base 5 of x divided by log to the base 2 of x minus 8, which from these formulas becomes limit x tends to infinity ln x divided by ln 5 whole divided by ln x minus 8 divided by ln 2. Now these get multiplied, which come in the denominator, and these two get multiplied, which comes in the numerator. So your expression looks like limit x tends to infinity ln x multiplied by ln 2 divided by ln x minus 8 multiplied by ln 5. Now these two are constants, so your limit would be only applicable to these values. Now if you substitute the value of x as infinity, you will get ln infinity, which is equal to infinity, and the denominator also becomes infinity minus 8, which is equal to ln infinity, which is equal to infinity. So your expression of ln x divided by ln x minus 8, and when you put the limit, takes the form infinity by infinity, and whenever after putting the limit you get the form infinity by infinity, you use the L'Hopital rule, which is this. According to this rule, if your limit x tends to a, fx divided by gx, where fx and gx are any functions, and after putting the limit you get the form 0 by 0 or infinity by infinity, and also your a can be any real number, infinity or negative infinity. Then in order to derive or compute the limit, all you have to do is you have to first differentiate the numerator with respect to x and the denominator also with respect to x, and after doing that you can compute your limit. So using the same rule, the differentiation of ln x is 1 divided by x, that is this. Now using these two rules, our expression becomes limit x tends to infinity 1 divided by x into ln 2 whole divided by 1 divided by x minus 8 ln 5. This is equal to limit x tends to infinity x minus 8 divided by x into ln 2 divided by ln 5. This implies limit x tends to infinity. Now this can be written as 1 minus 8 divided by x into ln 2 divided by ln 5. Now if you substitute the limit here, your x tends to infinity, that is, this will look like 8 divided by infinity, which is equal to 0. And 1 minus 0 is 1. And if you multiply 1 with any number, that would give that number itself. So this entire limit is equal to 1. So that would give you 1 into ln 2 divided by ln 5, which gives you ln 2 divided by ln 5. So which is your final answer. If you wish, you can compute these values from the log tables and substitute and get your final answer, but we are not doing that here. So your final answer is ln 2 divided by ln 5.